Hello everyone, welcome to AI Anytime channel. In this video, we are going to talk about Code Llama, which is a new large language model by Meta AI. It has been released in the last couple of days, and the community is talking about it that this is the most souted coding specific LLMs nowadays. Okay, so we are going to take this LLM and see how we can utilize it in a Python application. So we are going to build a simple Gradio application where we are going to leverage this LLM to test this on few of the coding problems. Okay, so we'll ask few questions and see what kind of responses we are getting out of this Code Llama model. So if you see here currently on my screen, it says introducing Llama 2, the next generation of our open source LLM. All credit goes to Meta AI for strengthening the open source community. They started with Llama, few months ago, and which was not available commercially as a license, but they came up with Llama 2, and the industry has followed. After the initial release of Llama, the first version of Llama, there was a lot of models like MPTs, Falcons, Vicunas, Alpacaids, etc., right? So now we see every week a new model has been released. But when it comes to coding problems, which has a different grammar, different vocabularies, different syntaxes, etc., it's difficult for a model, which might be a general purpose large language model. For them, it's difficult, to solve coding problems or to respond to your coding questions or queries. But when you talk about this Llama 2, you see here we come down, here they will have a new option called Code Llama. So they have a blog on this. So if you see, it says introducing Code Llama, a state-of-the-art large language model for coding. Coding is itself it's a very complex when it comes to training models on code corpus due to multiple regions, as I said previously. So they have trained on 500 billion tokens, and that's very impressive. License is something that you have to get in touch with your lawyer to understand the license of Code Llama. Jokes apart, but the licenses are a little weird to understand. But it says Code Llama is free for research and commercial use, but there are some clauses that you have to be really careful with. It depends what kind of enterprise you are representing. So if you see, it says Code Llama is built on top of Llama 2, and it's available on 3 different models. So the foundational code model, and which is a Python specialized Code Llama, and then an instruction tune. So instruction tune is something that we are going to look in this video because we want more human-like conversation. Because this model, the foundational model of Code Llama, they also have fill in the middle, that's called FIM, fill in the middle features, and the way they had been trained on those 500 billion tokens. But we are more, we are going to focus on the instruction tuned model of this Code Llama variant that we have, right? And again the same human eval, MBPP, and all has been, again the evaluation benchmark has been done on top of it, has performed really good, but we have to test it out, right? It performs good on some set of problems, but when you do it, test it out, it kind of struggles, right? So if you see, here is a high level view, single pane view that shows how the 3 variants in this Code Llama or the Llama 2 has been trained on. So the Python code training, which is specialized for Python, and then we have instruction fine tuning, and then the foundational Code Llama that we have. And all of these models are available in 3 different model weights: 7B, 13B, and 34B. In this video, I'm going to stick on 7B because I want all of you to try it out, and everybody would not have probably the machine to run this in their local machine. But I will show that how you can run it on a CPU machine or even on a GPU with the 7B model. Okay, and you can see the performances on human eval, MBPP, and multilingual human. That has been the benchmarking criteria for these LLMs. Okay, available on OpenAI leaderboard as well. The detailed and comprehensive views of this benchmarking. And you can see it's performed good. Okay, star coder again leads star coder prompted. Just to give you information, guys, if you don't know which model to select for coding, I will recommend 3 models, and then again you go and pick one of those. Star coder by Big Coder. They also have Octapack now recently that they have released. And then the other model is Wizard Coder. It's optimized, lightweight. It's very optimized when it compares Star Coder and Wizard Coder. They are talking about coding specific LLMs. 3 models. star coder. There also has a star chat variant of it, instruction tuned. Then we have widget coder, and then we have now Code Llama. These are specific to your coding problems. Go and pick any one of these models to build solutions, okay, or chatbot, whatever you are building. Okay, a lot of talking, guys. So what we have to do here now, okay, we are going to rely on Tom Jobbins again, the bloke from Hugging Face. You can see he has more than 800 models on his Hugging Face repository, okay, and we're going to rely on one of the model because I have applied for the access and all. It takes around few hours to get the access from Meta AI, and probably that's why in this video I'm going to show you that how you can take a GGML, GPTQ, or GG, basically, let me show you, GGUF model, okay, which has been supported by Llama, CPP, and Cobalt by last week. After last week, they have a new variant or new way of a model that you can run on community hardware. It's called GGUF, and also that, okay. So I'm gonna rely on Code Llama 7B instruct GZML. Okay, that's the model that I'm gonna rely on this video. Okay, so if you see here, this is the model that I'm gonna take. Okay, you can see this Code Llama 7B instruct GGML because I'm going to use C transformers in this video by Marella, okay, which is available on GitHub. I'll give you the link in description. I'll also show you that. So I'm going to use C transformers, which is a Python binding for C, C++, and I'm going to take that library to load this model, okay, through C transformers to run this on a CPU machine, by the way. And I'll also show you that how you can easily change it to a CUDA based kernels or something like that, okay, on GPU. So this is the model I'm going to take. Now how you can download that model is, if you come to files and versions inside this repository, you will see a lot of checkpoints, basically the model weights, okay, that is available here, the bin file, okay. Probably you can take it this, I'm gonna use a 4-bit quantized model, but you can also use a 8-bit quantized, which is little heavier, okay, a little bigger in the size. I'm going to take a 4-bit quantized. So this is the model I'm going to use it, and that is already available. Here I have downloaded this in my VS Code. You can see in my this directory which says Code Llama project, I have downloaded this file which is around 3.7 GB. Okay, so it's a directory. We have to keep this, and you have to keep requirements txt. Let's go back to VS Code. In this VS Code, you will see these are the requirements that you need. You don't need Streamlit. I'll just remove Streamlit from here. Let me just remove that. So you need C transformers, Gradio, Langchain, Fast API, and UVCon. Maybe I'll also remove Fast API and UVCon for now. We'll do in the next video where we will build a embedding based application through an microservice or API backend. So in this video you need C transformers, Gradio, and Langchain. That's what you need. I already have Torch, everything installed like transformers and all, and maybe I'll just do that in this as well. Okay, and I'm going to use WSL2 in this. So let me just do a clear. I'm going to use WSL2 for this. You can see I'm already in this directory, and I'm just going to use that. Okay, so let's create an app.py, guys. So app.py, and the first thing, as I said, I'm going to use something called from langchain.llms import C transformers. So I'm going to use C transformers. You can, if you don't want to use Langchain to at least load the model, of course you can use it for chain. I recommend that as well. So you can do it auto causal, as well. You can also do it from pre-trained. So let me just show what I'm talking about it. So what you have to do, you have to come here and say C transformers, okay, which is by Marella here on GitHub, and you can see you can also load it from auto model for causal LM, causal language model, which is a task, like you can define your task as text generation or something, and you can also do it from pre-trained. But Langchain already has this class in their like Langchain has this module, so we can use this C transformer directly from Langchain. That's what I'm gonna use, and then I need few more things here, guys. So from Langchain.chains, I'm going to use LLM chain because we are not going to create our knowledge base here. So let me just do LLM chain. We're just going to use how we can use Code Llama in a local machine and just through an app or something like that. Okay, so from Langchain.chains import LLM chain. From Langchain, the next thing is import prompt template. So we're gonna write a simple prompt template. That's it. From Langchain import prompt template. We need Gradio. Let me just bring few things. I'm gonna have import OS, import IO if need something. Then from, okay, not from, it's import Gradio, and you can also do make it sort. So we're gonna use it later. And then let's import time or something like that. Okay. Okay, cool. So that's for import. Excuse me guys, import time. And what we need is, now let's define a custom prompt. So what I'm gonna do here, I'm gonna say, okay, custom prompt. And in this custom prompt, let's call this custom prompt template. Little self-explanatory. We're defining a simple prompt template, and just let's have a doc string. And within this, what I'm gonna do, I'm gonna just write here that you are an AI coding assistant. Okay. So now assigning a role to this language model. So you would have seen different type of prompting techniques. And a very simple, now it's not a very comprehensive technique, but a simple technique that you assign a role, you assign a task, and you set some limitations, to that LLM, okay, through your prompt template. So you are an AI coding assistant, and your task is to solve coding problems and return code snippet based on, let me just do an Alt G, based on users, based on given users query or something like that, based on given users query. And let's not say below is the users query, and then here we'll define our query. So let's just call it, let's call this excuse me, I don't know what happened, query. And then here you go query, looks like something like that. Okay, basically this is dynamic, right? This is your query. That query will take it from the Gradio app. Now this becomes your query, and now you can just write, now you just return the helpful answers, something like that. Okay, just return the helpful answer, or let's make it more code. Okay, so I'm just gonna, you just return the helpful code there. Okay, and here we can write, let's you just return the helpful code and related details. Okay, and here we can just write helpful code and related details. That's it. So this is a simple prompt template that we have defined. Now what I'm gonna do, I'm gonna write a function. Let's call this set custom prompt, and that basically we're gonna use this prompt template. So set custom prompt. So the first thing is the prompt, and for that we are going to use prompt template module from Langchain, and in that you have to pass a couple of things. The first thing that we have to do is pass our template. So template is nothing but the variable that we have on top, which is custom prompt template, and then it also accepts if you are passing a variable. So we are passing query as a variable. In LLM chain, you probably need a single variable. When you have embeddings and all, then you will have your own context. So you can also pass that context, your knowledge base. Now in this input variables, which is variables, which takes the list, inside that list, you're going to pass your query. That's it. So, and just return the prompt. Here we go. So we have one function done, return prompt. That's it. Fantastic. Now what I'm going to do next is, okay, now we have this return prompt, guys. Now what we do next is that we're going to load the model. So let's load the model and then use this. So as you can also find it on the GitHub repository, that how you can use without Langchain. So let's now do that. So what I'm going to write is define load model, and in this load model, just let's load this model. So I'm going to call variable LLM C transformers, and here you can pass many parameters. The parameters will be available on Git. This is available on GitHub repository. What input params? Basically the inference parameters that you can pass here within C transformer. The first thing that you have to pass is the, I don't know why I have caps on here, so let me just do model. So if you are loading it through Langchain LLM, you have to write model, and if you are using directly from C transformers, then you have to do model path or repo ID. Okay, then you have to write model path. Okay, so please take care of that. Okay, because you might get error if you're just loading it directly from C transformers if you're not using Langchain, because probably it makes slow. So you can also do that. So model, and here I'm going to pass my model called Code Llama, and that's 7B model. So Code Llama 7B we are using an instruction tuned model. So instruct the file name, we are just passing the file name here, and I hope you downloaded that file. Now ggml and then version 3, ggml version 3.q4, which is quantized 4-bit underscore not, and then just bin. This is our, excuse me, this is our file name. So we are okay with the file name. You can see the left hand side here, Code Llama 7B, instruct ggml v3 and dot q4 and underscore bin something. Now what we're gonna do next is we also have to write which model type is that, which family it belongs to. So C transformer supports GPT family, it supports, now you have GPT-2, GPT Neo X, GPT-6J, whatever. It also support MPT models. Now you have MPT 7B, 30B, whatever. It supports Falcon, it supports Llama, so it supports different model family. So for that you have to write your model type. So in this we're going to write model type. Our model is nothing but Llama, so simply just write model type Llama. The next we have to write is max new tokens, and of course you can use all those parameters, inference parameters, after referring to their GitHub repository. Let's have 1096, keep it little, you can keep one night. You can also pass context size, guys. It's supported for Llama model right now through C transformers. Now max new tokens, and what else we need is, let's pass a temperature value. So I'm just going to write temperature. I will have a less temperature here because it's more coding problems. I don't want it to be really creative and return something which does not make sense. So temperature is 0.2. I think it's floating value if I'm not wrong. So temperature. And I'll also have a repetition penalty. So let's write repetition penalty, and I'm going to just pass 1.13, which is very standard for large language model. A repetition penalty to look at the repetitions of the tokens that we have. Now there are a few questions that people ask me, that can we also use C transformer through our CUDA kernels or the VRAMs that we have? So what you can do in that case, you can pass your GPU layers. I have 2 GPUs in my machine, but I'm not going to use GPU here for this because it's probably fast. It takes around 20 seconds to generate a response, but you can bring it down to 4 to 5 seconds on if you have a good VRAM. So on GPU layers, what you can do, you can offload some of the GPUs to layers to CUDA, and for example, if you can pass 10, you can pass 6, whatever GPU layers you have to pass. Of course, you should look at which model you are using in that case and how many layers you can pass it to it, right? So GPU layers, and what it also does, it also has something called stream, but I think that is available through the auto model that we have, right? The causal LM, because the stream equals to true, so you'll get an streaming response. So I'm not going to do in this case, but let me show you what I'm talking about. So if you come over here, they have all the configuration parameter. You can see the config and the parameter. Now if you see this stream, it's a boolean value, either you pass true or false. By default it is false, whether to stream the generated text. So if you can try it out in the terminal first, if it's generating the tokens in a streaming format like you see in the chat GPT. And also had GPU layers, the number of layers to run on GPU, it's 0 by default, it's an integer value. And you can see that how you have to do this C transformers CUDA, because it will install kubeless and all, right, for CUDA. Okay, so if you want to use CUDA on the C transformers, they will use kubeless and all, which is little heavy, around 500 MB size. You have to install that. Okay, and repetition penalty, that's it, right? So I'm not going to do a lot of things here and just return LLM. So let's just return this LLM here. So that's it, we are okay with it, guys. Now, so we have our define set custom prompt, define load model. With C transformers, we have this model type Llama, max new tokens, temperature equals 0.2, repetition penalty 1.13, and return LLM. And you can see the typos and all. If you get any error, it's fine. Now what I'm going to do here is I'm going to write the chain pipeline. So let me just write chain underscore pipeline, and in this I'm just going to use the function that I have written on top. The first thing is LLM, this is load model, so let's do that. And the second thing is custom prompt. So let's just do prompt equals set custom prompt, and just gonna use this function here. And here I'm going to use my chain, so let's call it QA chain, a variable. And in this QA chain I'm gonna pass in this QA chain what I'm going to pass is the LLM chain. So I'm going to use LLM chain module from Langchain, because I'm not utilizing my own knowledge base, so I'm not going to use retrieval or conversational retrieval chain, but of course we can do that. I'm going to do that in the next video. I'm going to create a video on some programming languages reference guide or some documentation, and we'll test it out how it responds. Now QA chain, LLM chain, and in this I'm going to pass my prompt, and prompt equals, so let's call this, let's not call this prompt, better to call this QA prompt, but it doesn't make sense. You can do prompt equals prompt, but just to avoid some terminologies conflict, so I'm just going to call it QA prompt. So let's just call it QA prompt, and in the next what I'm going to do is LLM equals LLM. Okay, this makes sense. So prompt and QA prompt and LLM equals LLM. Now let's just return the QA chain. So I'm just going to return this QA chain. Now this QA chain will help us pass our query and retrieve information out of Code Llama large language model. So that's what we have to do now, guys. So let's now do that. So maybe we can also print that, but let's first use it. So what I'm going to do here, I'm going to call a variable called LLM chain just to test it out. So LLM chain, I'm going to use this chain pipeline here. Okay, and we may test this out. So LLM chain pipeline. Now I'm going to use a Gradio application, few lines of code. So let's do that. So define function called bot function that will take query as an input parameter. And here I'm going to write I'm going to use that code, the function that we have written on top, chain pipeline. So LLM response, and here let's use that variable called LLM chain dot run. You can directly call this in function also, just like chain pipeline, okay, something. And LLM response dot run, and LLM response dot run, and here you have to pass, it's a function, okay, that dot run, chain dot run or LLM response dot run, which is a variable in this case. Then we pass a dictionary where we define our query, and then in that query it's a key value pair. So let's just do that, query equals query colon query, not equals. And then what I'm going to do here is just return this LLM response. So let's just return this LLM response. That's it, fantastic. And now let's build the simple Gradio application. So what I'm going to do here is with gr.blocks. So let's do that, gr.blocks, and it's a function, and inside this blocks what I'm going to do is I'm going to have my title, and of course you can use markdown HTML to make the title better, but let's do that. So Code Llama demo or something, Code Llama demo, and something like as demo. So let's call this as a demo, and within that I'm gonna maybe you can use that. Right now it will create the demo name, the app name in the left hand side, but you can configure this through HTML or something like that, markdown. Okay, now let's have a markdown here. So gr.markdown, and here I'm going to write let's write Code Llama demo. Okay, you can pass CSS also, guys, custom CSS file, something like that. Okay, Code Llama. Now what I'm going to do is I'm going to write my variable called chatbot. So in chatbot, then gr.chatbot, and in this chatbot, so gr.chatbot, and you can also give an element ID, which is elim_id. Basically the element ID, just to, if you want to use it some sessions and all later on, you better to give a element ID. So let's do chatbot for this element ID, and then you can pass height of that windows where we're gonna interact. So height equal, maybe you can have 7, let's keep 700 by now. Okay, so we have defined our interface. We need a chatbot which will have an empty list for now, element ID, just assigning an ID, and height equals 700. Now let's have a message variable. We're gonna have a text box. So gr.textbox, gradio.textbox. That's it, gr.textbox, and you can also have a clear button. So let's have clear button that will clear all the output if we need. Okay, so clear button. So gr.clear button, and I think it's caps. So gr.clear button, and just message and chatbot. That's it, and message and chatbot, clear button. I think it's a list. It has to go inside a list. Okay, so Okay, clear, and I think we are good now. So clear. So I'm gonna use that function for we need a respond function, so let's call it respond. So define respond, and I'm gonna pass my message, and you can also have chat history here. So let's do that. Message chat history, and it's a function. So I'm gonna have bot message a variable which is returned by the llama code llama bot message. I'm going to use that function that we have written on line number 44, the bot function, and I'm going to pass the message inside it. So let's do bot and then just pass our message bot message. That's it. So bot message, and then I'm going to have chat history.append. You can append that chat history, and you can pass message and bot message. So best bot message both history.append, and then you can also have a slip for few. So ms, so let's keep 2 for now, time.slip, and then just return. So return chat history. That's it. We are okay with it. Now let's submit that, guys. So what I'm going to do here is return, come outside of this function, message.submit, and in this message.submit I'm going to have respond. I'm going to have a list which will have message and chatbot, and then I'm going to have message and chatbot again. So that's it, message and chatbot. Okay, fantastic. Now what we have to do is, now let's launch this. So with GR blocks, and I think we're going to launch this now. So let's launch this application, which is a Gradio app. So what I'm going to do is demo.launch. And let me show you what we have done here, guys, from top quickly. So we have imported all the libraries. You can see C transformers to load the model, Langchain as a chain to interact with it, to retrieve some information through a chain. Then we have prompt template to define some template, custom prompt. Gradio to help you build a simple interface. And then we have a couple of functions. The first function is a custom prompt, leveraging the prompt. Then we have load model to load the model. Then we have chain pipeline, chaining the pipe, Langchain, bot, and GR blocks, title, code llama, demo as demo, markdown, etc., etc. So now let's run this, guys. So that's what I'm going to do in this video. Now to run this. Okay, so let's now run it and see what we are getting. So for that, what you have to do, you have to come here on. So I am using a WSL2. You can use any terminal, Anaconda, whatever you are using. Okay, virtual environment, whatever. Now let's run it and see what we are getting here, guys. Okay, line 45. LLM response. Okay, it's not LLM response, it's Langchain. So let's do that. So we did that, Langchain. Let's ask that question again. Alright. Function to design a login component in Angular. Error, local variable, LLM response reference. Okay, let's close this. Okay, to run it again. So now let's do python 3 app.py, and we'll again open this. Okay. And now what we have to do, let's just come here, let's just refresh this. Let me just copy this. Okay, so write a function to design a login component in Angular. So this is the question that we have asked here, guys, like write a function to basically design the write a function to basically design the login component. Now you suppose, for example, if you want to design a login page in Angular, how we can use Code Llama for that particular task, and to generate some code and then take that code to test it out if that makes sense. We will ask couple of questions, that this being the first question that we're going to ask, and let's see what it responds. So if you see it over here, we have asked this question to create, and it runs on this port 7873. So we are using a Gradio application here to see. So let's see what we get, and you can see we have got I don't know if it looks like me, it's a Java code has given, guys. To be honest. Okay, you can see public class login component. It does give a login component. Probably it would have been hallucinated, and write a function to design a login component in Angular. So first fail, and makes sense because we're using a 7B model. So don't expect that it really gonna be good. Maybe you have to use the 34B or 13B model, but even with I was expecting a much better response than this. I will ask this question again and see if I'm getting the same thing. So let me just ask this question again. So I'm again asking the same question and see if it generates the same answer or it generates something else, because we are not using seed and all, right? So I probably assume that it will give me some other answer that I'm expecting, because right now I think it has generated a Java code, which probably might be Java and Angular people have been using. I don't know. Okay, so and the code, I'm not worried about if the code is completed or not. Maybe you have to look at the max new tokens, to increase the token size, and also you can pass for Llama context size as well, context window size for that. So now let's see for this what it. I've asked this question again and see if it's generating the same response, or if you gives you the better code. Now meanwhile, let's go back to, and you can see here it says login form. Okay, email. This is great. Okay, this is not what I was expecting, but let's ask a simple question. Okay, so I'm gonna ask how to okay, let's ask this question. Write a Python code. That's why first I tried with Angular, but now I'm trying with Python. So write a Python code to connect with a SQL database and retrieve all the tables name. Okay, probably a far more easier question than the previous one. Now this is the question that I asked. Now let's see if it's response for that. Okay, now let's see that. So we were expecting much more than that, even with the 7B model, but which is okay. Maybe we have to use 13B model and try it out. How are we getting it? So when I see it for the first time and compare with Star Coder or Star Chat Beta, to be honest, it didn't perform that well. But let's see. Let's check this out. And I think this makes sense. So this is okay. So it uses PyOBDC, and it's connect with that SQL server, and this looks good. Okay, so this is fine. Okay, we'll try it out with some other questions. So let's do that. So so this makes sense to me, and let's see what Meta has asked. Okay, on their blog in Bash, how do I list all text files in the current directory that have been modified to how do I list, define, create, evaluate, define, create, evaluate ops. Okay, I have a CSV file with those headers. Order and correlation. Let me ask a question. Convert below, or let's write this. Let me go back to a Java, or simply let's ask this. Write a Python code that uses pandas to load a CSV file and then uses scikit-learn to train a linear regression model. Okay, add to dictionary scikit-learn. Also write the code to evaluate the model on some matrices. Okay, let's click enter and see if it's able to. So this one, the last one was okay. Write a Python code to connect with a SQL database, which is at least decent when you compare that with the previous two responses. Okay. Let's see that. Okay. So we'll see that if the complexity increases, how the model responds. Okay. Okay, and I think it has done well. So what it does, it imports pandas as PD, linear model, linear regression class. Then it loads a file, train linear regression X and Y, fit intercept true, fit and X and Y, no training and testing, by the way. No splitter and all. It assumed that you would do that. Okay, and then it evaluate linear regressions, has some matrices like MSE and MAE. Looks good, by the way. At least gives you some templates, right? It gives you some boilerplate to work with. And let me just take R code to linear regression, R code for linear regression. I want to test it out for the code conversion use case. So if it also performs for code conversion, R code for linear regression, and I'll open any data. What they do, data camp and all. Okay, so let me just copy this. I'm gonna copy this, and I hope this is for linear regression or what. Okay, let's use this and see if it's able to convert this code. So convert the R code to Python. Okay, I'm gonna paste this here and click enter, and you can see, right, it works well for Pythonic, at least Python as a language. Maybe you can also try it out some different programming languages, but Angular it didn't work that well. Maybe I didn't ask the right set of question. You can try it out, but this is my last question I'm going to try. Let's see if it's able to perform better R to Python conversion. And what I can also do, I can look at a Java code for database connection. And in that, what we can do here, let me just copy this set of code here. Okay, not much. This set of code, I will just cut this out now. I've just copied it. And after that, what we can do, we can also try it out on some automated test cases generation. And you can see it says import pandas as PD. Maybe what we can also do, guys, the prompt template that we have defined, right? Only return the code snippet and helpful answer. You can remove the code snippet and write helpful answer. Maybe you have to write a better prompt to get the best out of it, but it works fine. Now you can see import pandas as PD from sklearn.linear model, import linear regression. Define. I think this is fine, right? It got your R code, understood what you were trying to do, and maybe from the doc string or whatever, like comment and all. Now let's see this. Okay, write automated test cases for the code snippet. Let's see if it's write some code snippet. Okay, now I've taken a Java code and you want to generate some JUnit test cases or some kind of test cases using Code Llama. How we can do that, guys? And that's what I'm going to try, and this is going to be my last, to be honest. And it satisfies me as a 7B model. I liked it, and I'm really sure that when you go and use 13B and 34B, maybe we can try 34B after deploying it on AWS or somewhere and test it out, and I think that will be really fine, when it comes to 34B model. But this works good for me, so let's wait for this and see how kind of responses we are getting here. Okay. It takes right now, I am running on CPU, but I'll just show you my task manager as well. So you can run this on CUDA as well, and if you want, if you go to performance, you can see on GPU 1, GPU 0, GPU not. I'm not utilizing any one of the GPUs. GPU 0 has been utilized, by the way. You can see the memory is shooting up, but that's fine. And write automated test cases for the code snippet import didn't give you anything here that what I was expecting, and probably due to the prompt that we have. But that's all, guys. This is what I wanted to show in this video. Okay, and I need your comment and thought and feedback in the comment box. Let me know if you are doing something fantastic or some extraordinary thing with Code Llama. I'll be more than happy to collaborate, if needed, on that part. But I liked it as a 7B model, and I shown you in this video how you can take this model from Tom Jobbins, the bloke hugging face, one of the model. Try it out. You can also look at GGUF model, which has been supported by Llama CPP and Cobalt as well, and you can use this as well. This is what I wanted to do in this video. I hope you like this video, guys. If you have any comment, please let me know in the comment box, and the code will be available on the GitHub repository. And that's all. Okay, if you like the content, please hit the like icon. If you haven't subscribed the channel yet, please subscribe the channel, and please share the video and the channel to your friends and peers. Thank you so much for watching. See you in the next one.